We're continuing with review, and this is an example with modeling with mathematics. So calculus, there are a lot of discussions with rate of change and how things are related to each other. Rates of change are related to each other, and this question actually brings up some of those facts, the precalculus of the calculus concept, basically. And so an observer is viewing the space shuttle take off from a distance of 16 kilometers from the launch pad. The shuttle travels straight up with constant speed of 8 kilometers per second for the first part of the ascent. Let t be the time passed in seconds since the shuttle has been launched. Let theta be the angle of the elevation in radians. And so this is the picture that's so somebody's over here and observing the shuttle go up. This can be a cameraman, and he needs to know, he knows the speed of the shuttle, he knows his distance from the launch pad, and he needs to figure out the rate of change of how to raise his camera so he follows the shuttle, basically. We're actually simplifying this problem, but that's the eventual problem that we end up in calculus, basically. So the first part of the question here is express the vertical distance of the shuttle h as a function of time t in seconds. The constant speed 8 kilometers per hour per second, and that means that the speed is going to be the height is going to be the constant speed times time passed, because it starts at height equal to 0 and goes up. Now, the second question, express the angle of elevation theta as a function of vertical distance of the shuttle h in kilometers. Okay, so this one was something we knew from the past, how to relate the constant speed to the distance traveled, and that in here h is the distance traveled. Now this part of the question is asking relate theta and h. Theta is over here and h over there. We know from trigonometry that I have a 16 miles or kilometers over here, and I can use the ratio between h and 16 to find a ratio for a trigonometric ratio for theta. And so that would be tangent of theta is equal to h over 16. And so I use that first, but this question is asking to find theta as a function of the vertical distance. I related theta and h and no other variable in here, and that's the first part that I want to do. Now I want to solve for theta, so theta would be a function of h. And solving for theta, I get theta of h. You see over here I had h of t, then is h as a function of t. T is what the input is. And here is theta of h, and h is the input, is equal to arctan of h over 16. Over here I basically solve for theta, and then I remembered because theta is going to be a function of h, I use that notation of parentheses h in there. Now, the next question is express the angle of elevation theta as a function of time t. Oh, we just did express theta as a function of h. Now we're actually finding, let's see, it was theta of h and I had h of t. Oh, so if I want to express theta as a function of t, I need a composition of the two functions, is theta of h of t. And so that's what happens. The composition of function becomes arctan of, instead of h, 8t, 16, right? It was h of t, so it would be basically 8t. So the next question is, what is the vertical distance in kilometers when t is equal to 2 seconds? And I look at this part, that's the vertical distance, h in terms of time. I plug in 2 in here and I get 16. The next question is, what is the angle of elevation in radians when t is equal to 2 seconds? And I look, and angle of radiation, theta, as a function of time is right here, so I can plug in 2 in here, and I get theta equal to arctan of 8 times 2 divided by 16, and that is pi/4. So one thing that we want to, before moving to the next part of the question, next example, is to notice this. When you relate theta to a function of time, or when you relate theta as a function of height, this relationship in calculus, you can also relate the rate of change of theta to h or time, either one. This is how you calculate that rate of change in theta, and then that's, let's say, someone with a camera is standing there and trying to keep up with the shuttle. That person needs to know how fast theta is increasing, and so that's how you figure it out in calculus. And calculus part of it is another technique, but